This is the first part of a series of videos that I'm going to be doing explaining how to set up a game from scratch with Unreal. This will mostly be targeted towards people that have previously used Unity, but if you've never used any game engine before, you should be able to follow along and make your first game from scratch. So in this first video, I'm going to explain how to get hold of the engine, get it all set up, start your first project, then start bringing in some artwork, setting up some animations, and then getting a character moving around on screen. Okay, so first you're going to want to get yourself a version of the engine. This is the Epic Game Launcher. You can download it from the website. Grab a version of the engine. In this case, I've got 5.2.1. Just going to hit launch. So now that we've fully booted up the Unreal Project browser, we're going to see a bunch of templates to pick from. In this case, I'm going to pick blank, C++, and starter content. So the reason for this is I want a nice empty project with some C++ code. I want to bring in some starter content that's just some placeable meshes that we can mess with. Set the project location to somewhere on an SSD drive. This will really help with just compilation speeds, shader compilation, just anything that's involving disk read-write. It will speed things up drastically for you. Okay, and now set a project name. In this case, I'm going to call it First Project and then hit Create. In my case, because I've already created the project, I'm just going to hit Open on Recent Projects, and here we go. So to start with, let's go over the interface. First up, this is the Viewport. In Unity, this is called the Scene View. You can navigate by holding down the right mouse button and using the WASD keys as well as the arrow keys. You can look around by holding down right click and dragging the mouse. You can also zoom in and out with the scroll wheel, or if you're holding down the right mouse button and drag the scroll wheel, it will change the speed of the camera, so you'll move slower or faster. Okay, at the very top of the viewport, we have something very similar to Unity's toolbar. So for the gizmos at the top of the screen, we have selection, we have translation, we have rotation, and we have scaling. This button here changes depending on what you have selected, but it will cycle between world transforms and local, like object transforms. This controls snapping to surfaces. This button here enables or disables the snapping to grid, as well as the scale of the grid. This button enables snapping to rotations along with the size that you want to rotate to. And this one is for scale, along with the scale that you want to be setting to. This one controls the camera speed. Again, you can modify this with dragging the mouse wheel while holding down right click. And this button maximizes or restores the viewport. By default, it's always going to show a perspective view. These other views are, orthographic, top down, right, left. I just recommend having the single one for now. You don't need the other ones unless you're doing some more detailed work. This button here enables you to toggle between the different views. So top down, left, perspective. This one here controls the view mode. So you may have a need to show things in unlit mode, or just showing the lighting only, or just showing collision. Or if you're doing some optimization, one of my favorites is shader complexity. So this view here will help you track down expensive shaders that may or may not need optimization. And there's a bunch of other ones, but for now, let's just go back to lit. And the show button, this lets you toggle on or off different things depending on what you need. So if I wanted to show the collisions, for example, I would toggle that flag on and it will show all the collisions in the scene. By default, you probably don't need to see that. So on this side, we have the outliner. Unity calls this the hierarchy. It's effectively a list of all the assets in the scene, along with any folders and whatnot you've created to help sort things. You can drag objects out of folders or into folders and create a new folder by right-click, create, and then let's make a new test folder. You can toggle objects on or off with this I button here. Underneath the outliner, we have the details panel. Unity calls this the inspector. The details panel will list out all the properties related to the asset that you have selected in the outliner. If the asset has some editable properties, you can edit them all here. Lastly, we have the content browser. This is what Unity likes to call the project view. You have all your imported assets, blueprints, materials, etc. They're all organized in a folder structure. Each of these folders live on your hard drive. So if you right click and show in Explorer, it will open up the associated file in Explorer. You can search within the folder you have selected on the left-hand side by just typing in any asset name. So for example, if we wanted to find arrows, just type arrow and it will pop up all the arrow, anything with the word arrow in its title. If you press this button, you'll be able to select filters. For example, if I wanted to see only the materials in this folder, I can just tick materials and it will show me all the materials in this folder. Every single asset in the content viewer can be double clicked to open up its related editor. For example, this is a material. So if I double click, it will open the material editor. But if I was to select a static mesh and double click it, it would open the static mesh editor. As we have a brand new project with no content in it, except for the starter content, what I'm going to do now is import some artwork. This will include some animations, and then I'm going to go through the process of creating a basic character, setting up a controller, setting up the inputs, and then having you move that character around with those inputs. To do this, I'm going to grab some artwork from kenny.nl, which is a fantastic resource. If you don't already use it, highly recommend. Their work is amazing, and they continue to put out great stuff. So I'm going to open up the folder where the project is, and I'm just going to go to the very root of the project. I tend to put my raw artwork files, this will be the actual FBXs and the audio, the animations, etc. All the actual raw artwork, I will put them in a folder just above content. And I tend to call this art raw. Now I'm going to drag in the assets. So this is the animations, the models, and the skins. Now I've put the artwork in the art raw folder, I'm going to go into the project itself. I'm going to create an art folder. Now we have the art folder. What I'm going to do is go to the folder that has the art assets in. This is under the art raw folder. I'm going to grab the model, drag that into the art folder. This will be a skeletal mesh. I want to make sure that's ticked. And if there's any animations, let's import them in. Hit import all. Now let's also grab the skins folder. Let's grab that, drop that on top of the art folder. That will import the skins. Now the last one is the animations. So we'll drag that in, drop it in the art folder. This is slightly different. This is going to ask us for a skeleton. So in this case, we'll choose the skeleton that we've already imported, and it should map everything to that skeleton. So now we have the idle animation, the jumping animation, and the running animation. You may be wondering why I put things in the art raw folder as opposed to inside the content folder. So content refers to view assets normally. When I go to source control things, I tend to have the art raw folder in either a separate repository or just separated away, because when engineers are working on a project or designers are working on a project, they don't necessarily need to have the full FBX files or the giant PSDs. They don't need all of that. What they do need is the U assets that can render everything in game. Now that we've imported all of our artwork, we're going to create a gameplay folder. So in the gameplay folder is where I normally store the blueprints related to the game, along with all the design data that we may need in the future. To start with, we've got the animations. We want to set up the blend spaces to make it so the character can go between idle and running. We then want to set up an animation blueprint, which will tell that blend space how to run, which we could then expand later on in the future if we wanted to have different types of animations inside the animation blueprint. But for now, it's just going to be a simple run cycle. So let's just go create a new folder, animations. Right click, animation, animation blueprint. We choose a skeleton that we've already imported. Press create. You normally prefix this with ABP, which is animation blueprint. And we just call this animation blueprint character. So you see how when you load this up, it is doing nothing. It's just in a T-pose. So what we want to do is right click, animation, blend space. Again, choose a skeleton. We call this blend underscore movement because this is going to have all the movement animations in it, along with the idle. So what we do, we grab the animation sequence for the idle, drop that in, and you see how they're idling. So we'll set up the axis for now. So this is horizontal. The minimum is going to be minus 100 and the maximum is going to be 100. Vertical axis, we're just going to call vertical. Minimum minus 100, maximum 100. And what we'll do, we've now dragged this animation in and we'll just set it to the center. If you want, you can right click and just type in the numbers along with modify the rate scales and whatnot. If I hold down control, it's going to preview the animation depending on where things are on the blend space. But as you can see, there's only 1 point, so it's always going to be idling. So let's add the second point, which is this root run. And now let's set the horizontal to 0 vertical to 100 because we want it to be at the top. Now, if I preview, 0 is giving me an idle and 100 is giving me a run. What I've done here is I've copied this animation sequence for the run and I've made a backwards version. All I did there, I changed the rate scale to -1. Normally you would want to have an actual animation for this, but in this example I just wanted something quick and easy to show people, so I'm going to use a reversed run animation. Alright, so let's drop this in and we'll set that to 0 and the vertical to -1. So now, running backwards, running forwards. There we go. In the animation blueprint, we're going to grab the blend we just created, drop it in to the animation graph, and you see how it's now asking for a horizontal and a vertical point. We haven't set this up yet, so for now, let's just connect that to the output pose, and you'll now see the character idling. What you can do in the future is, as your animation blueprint grows in scope, you can add blends between these different animations, so you can have multiple blend spaces with different blends all triggered by different logic. But for now, it's really simple. It's just a forward and backwards. So for now, let's just expose these variables here. So if I right click, promote to variable on both of these. So we have two properties on this animation blueprint, vertical and horizontal. They will then drive this blend space. Right now it's only in the vertical, but if we wanted to add horizontal animations, so like side shuffling, it would also drive that. And that's the animation blueprint setup. So let's go and now create the character itself. So let's right click, blueprint class, character. So BP underscore character. BP being blueprint. You want to kind of keep short prefixes just to make things easily searchable in the future. So BP underscore character, we'll set the animation class to be ABP underscore character, which is the one we just created. We'll set the skeletal mesh asset to the character, and you'll see the character is now in the air, floating. Normally, when you create assets, you want it to be created at a certain scale. In this case, what I'm going to do, I'm just going to move it into the capsule and scale them down just slightly, just so they fit. This isn't the best practice, but I just want to have something nice and straightforward for now. So the character is now going to fit within the capsule. And you see they're doing the idle animations because they haven't been fed any information as to moving forward or backwards. They're just going to be doing the standard idle. Okay, so let's save that. Now, if we was to press play right now, it wouldn't spawn us as the character. It would spawn us as a default flying camera, which has some camera inputs. That's not what we want in the game itself. So what we need to do is set up the game mode and tell it what character to use. So to do that, you notice in the world settings, there is game mode, and the game mode override is set to none. So what we need to do is create a game mode. So again, right click, blueprint class, game mode base, and this is going to be GM underscore first project. And then we'll drag that into the override. Now I've opened up that blueprint. You see where it has these properties here for player controller, player class, default pawn. What we want to do is, instead of default pawn, set that to BP character, which will set it to the one we just created. And then we'll press play. So now you may notice that you have no inputs, you can't rotate the camera, you can't do anything, but if I just eject from the character real quick, it has now spawned the character we just created. So the reason it's not responding to any inputs is because we haven't set up any bindings on that. So to do this, there's two ways. You could do all of the bindings via Blueprint, but the version I'm going to show you is what I would normally do in a production ready game, which is I set up a C++ base class for the character and then set up the bindings in there. So we'll do that now. So to start writing some C++ code, what we want to do is first open the project folder and then open the solution. So in this case, I've already opened it. I'm using Rider. Your version may be slightly different. You may be using Visual Studio, but the code will be fundamentally the same. It's just the IDE that's slightly different. So what I'm going to do is create a new class. So in Rider, they have this great function where I can right click, add Unreal class. I can then choose which class I want to inherit from. So in this case, I've created a character. You hit OK and it will just create the files. So I tend to put my header files in the public folder, and then the C++ implementation, I put that in the private folder. Personal preference, you could put everything in the root folder, but for me, I just like having this slight division. You can even have subfolders within this, so this could have a character folder below that. But because it's a simple project with very little code, I'm just going to keep it as is. So let's walk through the code that we've got here on the screen. So the first function we have is the setup player input component. This is an override of the base version. The base version basically does nothing. It just checks to see if this is not null. In our version, it will actually bind to an action which we'll set up in the future. In our version, it's going to get the player input component, then bind an action to it, which will fire this handler. It will be triggered every frame as long as the input is held down. So for example, if I'm holding down the W key, it will keep firing out the outputs. Okay, let's go back to the header. And then we also override the pawn client restart. This is so we can first grab the player controller. We then grab the enhanced input subsystem, which is for that local player. Then we first clear all of the mappings that are currently associated with it. And then we add a new mapping context. This new mapping context will then tell it how the bindings are all set. So for example, it will tell it that WASD is the input for movement. And then we have the handler for the movement input. This is just going to take, every time this binding is fired, this movement action binding is fired, it will put the value here. We will then take the forward direction that the character is facing, and then we'll move the character forward using the Y value here. And then for the X value, which is A and D, or left and right arrow keys, or D-pad, or whatever you've set it up to, the actor's right vector, which is 90 degrees to the forward vector, it will then move the character left and right based on what the value is currently set on the X value. So the code's relatively straightforward. You notice how we don't have a tick function here. So in Unity, you would call that an update function. In this case, this handler is going to be fired as long as I'm holding down any of the input keys that I've bound. And lastly, we add these two properties, the input mapping context and the input action movement action. You notice how the category here has a string along with the pipe symbol here. This is just so it shows up better in the editor. Now to actually get the character using this, we have to do another thing. Now you've saved the file, you actually want to compile it in the engine. So there's this little button down here, which is kind of hidden. So if you press this button in the editor, it will recompile all the code. It will basically hot swap them out, similar to how Unity does it. So remember how we set our blueprint character? We had set that to the parent class of character, which is the base class. So if we look here, we are inherited from the A character. So we actually want it to be first project character. So to do this, open the full blueprint editor, go to class settings, and change the parent class to first project character. So this can be a destructive action if you're changing it from a class that doesn't have the same properties. It will lose the data. So be careful when you do this. In this case, it's just adding additional properties to it, so it won't actually lose any data, but just be aware if you do that. It will warn you if you try and do that. Okay, so now go to class defaults, and we'll see binding, which is this new properties that we've added, input mapping context and movement action. Because we've set it to edit anywhere, we can basically edit it in the blueprint. We could add it in a positioned character. Not that we want to, but in this case we can. We need to now create the input mapping context asset and the movement action asset. So to do this, go to gameplay. I'm going to create a new folder called input. Right click and then go to input, input mapping context. I'm going to call this IMC_player. And then we're going to also right click, input, and then we're going to call this IA_move. This movement, IA_move, what we're going to do is change the value type to vector2D, because we want our W and S to be pushing a Y value of 1 to -1, and we want our A and D keys to be pushing a value between -1 and 1. If we go into the input mapping context, we can add our first mapping. So we'll drag IA move into that mapping. So you notice it has a single binding to begin with. You can add multiple underneath this action. And if you just click this button, you can then press on the keyboard the key you want it to be. So W, A, S, D. Now what would normally happen is when you hold down that key, it will just return the value of 1 or 0. Because we're using a vector, what we want to do is add a modifier to this. We're going to first add an element, and then we're going to drop down and we're going to press swizzle input axis values. So the way swizzle works, it just basically swaps X for Y or whatever you set it to. So in this case, the order is going to swap the X and Y axis. By default, everything's on the X axis. So we want the W key to be positive Y. And then we want the A key to be negative. So we're going to set that to negate, which will basically just invert the value. So if you're holding it down, it's going to be -1. The S key, we want that to be swizzled on the Y axis. So Y axis. And then we also want it to be negated. So we want to swizzle. So we take it from the X axis being +1, we then swap it so it's now on the Y axis, and now we negate it so it's now -1. So if I hold down the S key, it will say -1 on Y. And then on the D key, that's nice and simple. We have no modifiers because if I hold down D, I want it to be on the X axis, I want it to be positive. So now we hit save. So if we just quickly go back to our code, the input handler, which is going to be triggered every time someone's holding down any of those keys that we've just set, we're going to take the vector value and we're going to take the y-axis value and move forward and backwards with that, and we're going to take the x value and move right or left with that. So remember, as I set d to +1 on the x-axis, it will mean moving right, but if I want to go left, I have a bound to the negated version of their value, which is on the x-axis as well. And on y, as I've explained, we've swizzled the value from the x-axis that it defaults to into the y-axis, and then we've inverted for the S key. I know that sounds really complicated, but when it comes down to it, it's quite straightforward. If you wanted to, you could change this from WASD to arrow keys to having D-pads set up. It supports everything you can imagine. And the one thing that's really handy about this is that we can make these player mappable. So if you ever have an option screen where you want to change the key that the player's bound to, you can do it via this. I'll explain that in a later video, but just know that you can do it in here. For now, let's just save and close. So now we've created these two assets. What we want to do is set them to be used by the character. So we open up the character, we go to our new properties that we've created, we drop down, we set IMC player, and then the IA move. Now if we hit compile and save, when we hit play, you'll notice the character is now able to move around. But you'll notice the next problem. If I move my mouse, I'm not able to look around. So to fix that, we need to extend the code so it supports a look action. It's also then bound correctly to the mouse inputs, but I'll leave that for the next video. So thank you for watching, and I'll be back very soon with a new video. I'm trying to get as many as I can together as quickly as possible. If you have any questions or you want to know how to do certain things in Unreal, let me know and I'll make sure to put a video up just for you. Yeah, hit me up on Twitter. I'm always around, available for questions. Hopefully this helps get you set up and maybe situated if you're just coming over from Unity. So see you later.